Good morning, everybody. Welcome to Life Sciences Grade 10. My name is Tutuzile Kupega. My email address is dkupega2204@gmail.com. So like I mentioned to you on Friday, today we will finish up with that section of mitotic phase before we start with the revision or preparation for the assessment. Ne? So now this lesson, depending on how quick we finish, we will do the mitotic phase, and if we finish early, then we will start with the revision. But if we don't finish early, then we'll start with revision tomorrow. So mitotic phase, remember what we discussed? How many stages are there in the mitotic phase? Who remembers? Before we even continue, who remembers? Wow, you all are in a good mood today. Morning, Santuri. It is 4. Which ones are those ones? Does anyone remember which ones? You can even tell me how I taught you to remember them. There, we've got the mitotic phase composed of 2 tightly coupled processes, right? There is mitosis and cytokinesis. So remember, mitotic phase has 2 processes, which is mitosis and cytokinesis. Yes, Nathaniel, it is PMET, which is prophase, metaphase, anaphase, and telophase. Those are the 4 stages in what? 4 processes in 4 phases in mitosis, which is the first process you find in the mitotic phase. The second process you find in the mitotic phase is cytokinesis. Under mitosis, which are the first 4 processes, you've got PMET, as Nathaniel is telling us, which is the prophase, metaphase, anaphase, and telophase. Thank you so much for that, guys. I really like it when you listen and apply. So these are the 4, ne? The 5th one is the cytokinesis, which is actually the second process in the mitotic phase. There, like I told you, and I'm so glad, you know what, Nathaniel, it shows me how much you understand, because you were very specific to only selecting the ones that are involved in mitotic phase, which is the PMET, because you understood that interphase is not part of the mitotic phase. Interphase has 3 processes on its own, or 3 phases, right? Which is the G1 phase, S phase, and G2 phase. So we already covered that. A recap of prophase. During prophase, the chromatin material will shorten and thicken into individual chromosomes, which are visible under the light microscope. And each chromosome consists of 2 strands or chromatids joined by a centromere. I even showed you the diagram of a chromosome so that you can be able to visualize it and understand how it works. So this is your cell, this is your nucleus, this is your nucleolus, the one in yellow there. Then the strands are the chromatid strands, the chromatins. So chromatin will do what? It will thicken and shorten to form this chromosome, which has a centromere. So this is drawn like this. So during prophase, what actually happens in prophase? In prophase, this is when the shortening and thickening of the chromatin material happens. So when you think of prophase, think of shortening and thickening of chromatin material, the chromatin material, that is the one that is shortening, as you can see this diagram. It's long, thin strands here. Then here, after prophase, during prophase, this is what happens. It's shortening and it's forming, it's getting thicker. Then, as prophase progresses, the nuclear membrane and the nucleolus disintegrates. So you have your nuclear membrane and you have your nucleolus. They will disintegrate. But the disintegration happens differently in animal cells and plant cells. For animal cells, the centrioles. Remember I told you the centrioles. What are the centrioles? Let me test you rather. Let me not spoon feed. What are centrioles? I told you already. So I'm basically asking you something I just told you. Centrioles, what are centrioles? These are the centrioles, guys. Let me draw. With a yellow color, ne? Okay, you have your chromosome. Then the center here, that circle at the center, that is your centriole. What does it do? Because it's holding together, you see, I've mentioned here, they are joined by a centromere is that center over here. That's the centromere. You understand? Please tell me, you understand? Are you following? But then what happens during prophase? The centrioles would separate. So this dot over here is the centromere. That dot is the centromere. So let us not confuse the terminologies because they sound so similar to each other, right? Let's not confuse the terminologies. The centriole is those cylinder shapes. They are cylinder or tube-like structures. Remember when we spoke of the cylinder or tube-like structures? It's those ones that they are there, they are present, and they aid in what? In cell division. So what do? They will separate and move to opposite poles. When they move to opposite poles, then the centrioles will give rise to the spindle fibers which form between the poles. In plant cells, though, there are no centrioles to move to the poles, so spindle fibers form in the cytoplasm. We studied about centrioles when we did organelles last week, and yeah, the past 2 weeks. We did organelles and we did centrioles. And you will remember about centrioles, this is also one of the things you could use when you are differentiating between animal cells and plant cells. In animal cells, there's a centriole, but in plant cells, there are no centrioles. So they can't be moving to the poles. So what happens then? The spindle fibers would form in the cytoplasm. But in animal cells, the spindle fibers would form in the nucleus, whereby the centrioles have went to the sides. This is the structure of a chromosome. Whenever you're asked to draw a chromosome, wherever you see this diagram, you'd know that is a chromosome. One is the chromatid. There is the chromatid. And then two and four, these are arms of the chromosome. 2 is the shorter arm, 4 is the longer arm. And then 3 is the centromere, that small dot there that is connecting or joining the 2 arms, meaning it joins the chromatids. No, I showed you the video, but I won't watch it with you because we've already watched it together on Friday. Human cells, we also discussed about chromosomes, that human cells have 46 chromosomes. You have 23 from the mother and 23 from the father. This is what you know. But then tell me, how are the sperm cell and egg cell different with regards to chromosomes? What is the difference between sperm cells and egg cells regarding chromosomes? How do they differ from the rest of the human cells? This is the special quality. It's the one that makes them differ. So remember all you know about chromosomes, about cell division. I haven't discussed with you that, no, I can't give you the answer. How do they differ? during cell division or during reproduction, when fertilization is going to happen, right? When fertilization is about to happen, it will be the fusion of the egg cell and the sperm cell. Both of them will then make up the genetic information of the offspring, right? So, since we know that human cells have 46 chromosomes, the answer is actually right here on the screen. It has 46 chromosomes, each cell. But somehow, when it passes to the baby during a fusion, why then does the human body still only have 46 chromosome or 23 pairs? Because if this is the case, let's look at this. Human cells have 46, right? Meaning you yourself, in your cells, you have 46 chromosomes. Let's say everyone have 46 chromosomes. Then why? Because your mother has 46, your father has 46. Why is it that you still have 46? How is this 46 maintained? Because if it's the sperm cell that is fusing with the egg cell, it is 46, 46, according to this information, right? Then you are not supposed to have 46. If these two fuse, it's supposed to be 6 plus 6 is 12, 2 carry 1, 4, 8, 9, 92, right? Yes. 92. This is the number of chromosomes the offspring is supposed to have. Offspring is supposed to have. But we know that is not the case. We know that the offspring also has only 46 chromosomes. So explain to me why it doesn't happen like this. How come the egg cell and the sperm cell fuse and yet their product still has only 46? Okay, Santur is saying egg cell has X cells and sperm cells have Y cell. This determines the sex of the baby. Okay, that is true, but what I'm asking about is particularly why even the offspring or the baby we are talking about here would still have only 46 and not 92. Okay, I see Nathaniel. Nathaniel, you understand this topic, ne? Nathaniel is explaining to us that the reason is because of the reduction division. So, in simple terms, what this means, just in simple terms, what this means is the mother has 46 cells in their egg cell. Even the father has 46 chromosomes, I'm sorry, 46 chromosomes. This is the father. Even the mother has 46 chromosomes. But what actually happens is they will each pass on only 23. So only 23 chromosomes from the father and only 23 from the mother. So it means they only pass on one copy because chromosomes are like this, right? They're always in pairs. So it means the mother will only transmit one copy of her DNA, of her chromosomes. And yes, it's DNA. And the father will also only transmit one copy, right? The father, so this is back to Santuri's answer as well, will transmit only one copy. And that is why it would happen that the baby is a boy, meaning the one that got transferred from the father was the Y chromosome. But if it's a girl, it means the one copy that was actually transferred was the X chromosome. So what makes the egg cell and the sperm cell different is that, yes, you'd still find 46 chromosomes in the egg cell, you'd still find 46 chromosomes in the sperm cell. But there is reduction division that occurs, which ensures that only 23 would be passed on to the offspring from each parent. You understand that? And that is why you will not end up with 92, because only half will be transferred to the baby, only the other half will be transferred to the baby from both parents. And then the baby will be 50% mother, 50% father. Is that clear? That's why at times the baby would like maybe have the mother's hair, the father's eyes, things like that. So this is the process of prophase. They're from chromatids, then it thickens and shortens, then it disintegrates the nuclear, the membrane and the pores, they disintegrate, and the spindle fibers form. Metaphase, remember I said how to remember metaphase? Just think of the M in metaphase as middle. Why? The chromosomes are appearing in a straight line across the middle of the cell. So it's just like, think of middle. Even when I show you diagrams, I can show you diagrams put together. You should be able to identify based on the diagrams, based on the position of the chromosomes in the diagram, as to which process is this. So when you see chromosomes lined up in the middle of the cell, there in the middle of the cell, that is a metaphase. Even in the plant cell, they are in the middle there. That is your metaphase. You see the spindle fibers are fully formed now. There, the spindle fibers are formed now. They are there. Anaphase, we didn't discuss anaphase. How I remembered anaphase, let's think of the A here. During anaphase, the chromatids are pulled to opposite poles of the cell by the shortening of the spindle fibers. The chromatids are now called daughter chromosomes. Remember, your chromosome is like this, right? You have chromatids, right? This is the chromatid, this is the chromatid. So during anaphase, they will now be pulled to, I want to show you the diagram. I didn't put together a diagram of the anaphase. Let me go show you. Let's go Google it. We'll go Google it. But basically what you expect to see is they are now separating. The other chromatids, see from this picture here, I'm gonna draw for you the anaphase image. This is your cell. Excuse me for the drawing, that's not very nice. So you'll have on one end here, they are moving closer because the spindle fibers are shortening, meaning the spindle fibers will probably move towards here, or they are just shortening a lot. So this chromosome here, the anatids will separate because the chromosome is like this, right? Meaning now the one part will go to the left, the other part will go to the right. What we call this is the anaphase, the A meaning apart. The chromosomes or chromatids are now moving apart from each other. And the chromatids will now be called daughter chromosomes because now they are going to the end there. They are going to divide now. So they need to be split. There, anatids there, the chromatids. Let us go Google so that we can see anaphase on Google. Let's see if we can find anaphase. I spelled it wrong. There. See an image. You see what's happening? They are moving apart. There. They are moving apart. You see? Apart. Apart from each other now. Apart from each other. That's why the A here, I'm saying it's, you think of it as apart. The chromosomes have separated and are moving towards the poles. The spindle fibers are shortening, as you can see, so they are moving towards the poles. And do you see the centrioles there? Those cylinder-like shapes I told you about, they are moving towards, the centrioles are the ones that form the spindle fibers. So the chromatids are now moving towards those poles. They are moving towards the poles over there. So that's how you can draw your anaphase. They are moving further apart from each other towards the poles. You should note, in plant cells, there are no centrioles to move to the poles. So spindle fibers form in the cytoplasm. I told you this, right? They will form in the cytoplasm. Then when they've moved to the poles, right, they are separating, they are moving apart from each other. Telophase, the last stage in mitosis. During telophase, a nuclear membrane reforms. Remember, it had dismantled or disintegrated during prophase. During prophase, the nuclear membrane had disintegrated, as well as the nucleolus. Remember, they both disintegrated. Now, in telophase, it is reforming. It is reforming around the daughter chromosomes, because remember from anaphase there, so you have your, let's say here, these are the spindle fibers. There, you have your spindle fibers. Then let's say it's your chromatids that are moving. There are your chromatids moving apart, right? They are moving apart. There on the, towards the poles. These here are formed by the centrioles. Remember, there, the main center, there is the centrioles. So what happens here? They are splitting. So what will happen now when the nuclear membrane reforms? Let me show you the nuclear membrane in a different color. The nuclear membrane will reform around this one here. They will reform around the daughter chromosomes. And through the reformation of these, the nuclear membrane, what actually happens? Do you see that the cell is now dividing? Now you have the one cell on this side, the other one on that side. The daughter chromosomes will then uncoil, because remember they had thickened in prophase, ne? Remember the processes in prophase. It's actually, so think of it this way. What happens in prophase is undone in telophase. So the opposite, what happens in telophase is the opposite of what happened in prophase. In prophase, the nuclear membrane disintegrated. In telophase, it is reforming. In prophase, the chromatin strands, which are thin and long, were thickening and shortening, right? But now, and how do they do that? They coil. Remember that DNA is a coiled structure. It coils, right? It coils, and you remember that chromosomes are actually very, very coiled structures of DNA. So what happens now in telophase? These daughter cells will uncoil. So it explains why they were shortened, because they actually coiled. They were shortening. So when you think of it, you have a long rope. Let's say you have a skipping rope. It is long. What happens if you want to put it away, tidy it up? You will coil it, and when you're coiling it, it will become shorter and thicker. So that's what happened in prophase. Now you want to go play with your skipping rope again. So you will uncoil your skipping rope. So now it will form again to become those, to become chromatin once again. But now this chromatin is forming whereby now you have two cells, based on the fact that the nuclear membrane has reformed. So now you have two cells. Is that clear, guys? I hope you understand. The nuclear membrane has reformed. So there, this nuclear membrane is reforming. You see here, it's reforming now, creating two cells. Nuclear membrane is reforming. Then there you go now. It's now recoiling to form chromatins again. Chromatin, which is the long strands of DNA, thin in structure. And in the plant cell, you can see the formation of the two daughter cells happening here. Guys, are you following? Is this, am I explaining it well? Any questions before I continue? I really need you to do it like this. It's possible to get straight A's on this subject, because it's all about study work. And if you are struggling, ask questions, Google, go to YouTube, that's why I'm trying to incorporate even videos in the lessons, so that at least you can get different perspectives of learning, because we need to do well, and it's possible for as long as you apply yourself. So please, if you have any questions or you are slightly confused about anything, you can even text me here, chat privately, and I will explain to you. I'll explain it in class. But basically, this is the steps now. Telophase, we are done. Now this is the daughter cells are forming. Remember? Then, now we are moving to the second process of mitotic phase, which is cytokinesis. What happens during cytokinesis? The cytoplasm is then dividing during a process called cytokinesis. This, again, it's important to remember, it is not a stage of mitosis, but the process of the cytoplasm splitting into two. So during telophase, the cells, the two cells, it hasn't really formed two. You see, it's just still, the nuclear membrane is still reforming, still trying to reform. But now, it's now even the cytoplasm that will be splitting into two. In an animal cell, the cell membrane constricts, meaning it's to constrict is to, you know, when you constrict, what do I say? You are reducing size, you are closing it up. It's closing up, it's it's constricting. This invagination or infolding of the cytoplasm, look here, it's trying to infold, as you can see, there's infolding happening here. The infolding of this cytoplasm will divide the cell into two. But in a plant cell, a cross wall is formed by the cell plate dividing the cytoplasm in two. Why? Because plant cells have a cell wall. So that's why this cross wall will then be the one forming. But in animal cells, it will just be the membrane that will constrict. There is the diagram of the cytokinesis. They are now two. So in cytokinesis, that's the stage where you will now see two fully formed, genetically identical daughter cells. They are identical to each other and to what? To the parent cell. So remember, the parent cell looked exactly like this. So now you see, even the nucleolus is back. It has reformed. Now your chromatin strands are there again. The nuclear membrane is fully formed once again. So you have your cell, but now the difference is you have two cells. You have two cells the same way we had the cells in the beginning. Let's go look at those cells from the very beginning. Oh, I hadn't shown you there. Those are there. Here, that's when the spindle fibers are forming, but it's quite similar. So this for a process that already started, actually. Is that clear, guys? So quick recap before we continue. Anaphase, what happens? Who can sum up the whole process of mitosis to me? Who can sum up? Okay, I see one answer so far. I'm waiting for the other ones. I'm waiting for someone else to also answer. At least. Oh, I almost missed Nathaniel's question. Let me go quickly to that part. Nathaniel is asking about, oh, you base. Nathaniel is asking if the cross wall is the same as the cell plate. Okay, this section here says in a plant cell, a cross wall is formed by the cell plate. So it's not really the same, it's similar, but what happens? The cell plate is the one that will form the cross wall. What is the cell plate? That plate is the one that develops at the midpoint between these two groups of chromosomes, when the cell divides. So when the cell divides, the cell plate is that one that will develop at that midpoint. Remember when I showed you, especially it will be clearer when you see in telophase there. So in animal or in plant cells rather, that one there, the cell plate, instead of like in the animal cells, remember the differences in the animal cells and the plant cells? In animal cells, it is the cell membrane that's constricting, right? But in plant cells, it is the cell plate that is the one that will be forming here at this midpoint. So here, let me use a color. It will be forming at this midpoint where the cell will be dividing, where these chromosomes are dividing. So the cell plate is the one that will form there. It's also involved in what? In forming this wall between the two new cells. What is that wall? So it forms here to allow the division to happen. It forms the cross wall. So it's not really the same thing. This here cell plate is the one that is responsible for the formation of the cross wall. Nathaniel? Is the cross okay? And then Santuri says interphase is the longest phase. It has 3 phases. The mitotic phase has 2 processes, which is prophase. Okay, wait, let me start afresh. So Santuri is trying to explain and summing up all this that we did together, the mitotic phase, right? He's telling us that interphase is the longest phase, which has 3 phases, and the mitotic phase has 2 processes. Then he's now explaining the different phases. He says prophase, the chromatin material will shorten and thicken into individual chromosomes. Then the metaphase, the chromosomes line up on the equator. Anaphase, the chromatids are pulled to opposite poles of the cell, and then telophase, the nuclear membrane reforms. Yes, that is a very nice summary. That is very, very correct. Okay, and then Nathaniel's summary is, mitosis is the process of cell division where 2 identical daughter cells are produced. Yes, that is correct. Diploid to diploid, good, because why? The daughter cells, why is this? What does it mean when he says diploid? He means exactly that, this here. The original parent cell was exactly like this. Even the daughter cells that are formed are identical to the mother cell. So this means where if the mother cell had like about maybe 2 chromosomes, even the daughter cells that form would each have about 2 chromosomes. They are exactly identical, diploid, diploid. So no, basically the only division that took place was to form the 2 cells which are identical. Which allows for what? It allows for growth, for reproduction, and asexual reproduction. Thank you so much, Nathaniel. I have a feeling you've done this topic already. Yes. Did you do it, Nathaniel? Oh, what? Where have you done it, or you just studied? And Santuri too. Tell me if you've done it in school, but I don't know how. But hey, there. So you see the daughter cells that have formed, they are genetically identical. Now I'm going to play a video. Do we still have time? Oh, I don't know how long this video is. Anyway, guys, let me say this. Oh, okay. Thank you. Wow. I'm very proud of you guys. Keep up that attitude. It's nice. You see how it's easier to even ask questions because you've already studied the work. So you know exactly what you know and what you don't know or what you are not sure about. And it makes learning easy and the class more relatable, right? Thank you so much. Please keep it up. And then now I'm going to play a video for you guys. It sums up the whole process of mitosis. But I'm afraid if we get cut out, we won't. It's 2 minutes, guys. We can't. I'll play it for you tomorrow, ne? But tomorrow I'll just play the video. Then we get on to revision to prepare for the assessment. So that's what I'll do. Because I see it's like less than 2 minutes left. It will definitely cut us off. Yeah? I promise tomorrow, as soon as we start class, I play this video. It will revise mitosis for you. Then we shoot straight to revision for assessment. All right, ladies and gentlemen, the links I used is the Snaplify app to access all CAPS textbooks, as well as the Siavula Grade 10 Life Sciences textbook. If you want to be able to get about maybe 100% for this assessment that I've said, go through Siavula Grade 10 Life Sciences textbook. Then, yeah, you will be fine. But even if it's the work you did, because in first term and second term, you did this work in your class. Okay, I have a question here. There's a question that says, can you please explain the division of the cytoplasm for me again? Okay, can I do it? Where is the division of the cytoplasm? You want this part of the cytokinesis, right? Remember with telophase. Telophase, what is happening now? The nuclear membrane is reforming, right? The opposite of what happened in prophase is happening now. The nuclear membrane is reforming. So now this is a division. So it was like one whole thing. Now it is reforming through the infolding. So when it's infolding, it's moving inside, like have a balloon, try and form two parts of a balloon, basically almost something like that. So that's how it's happening here. It is dividing. Né? This is a process whereby now this cytoplasm is dividing through the infolding of the cell membrane, of the cytoplasm. But what exactly is happening? In the animal cell, based on the structure of the animal cell, it is the cell membrane that will constrict, because the cell membrane is the outermost layer of the animal cell. But in a plant cell, the outermost layer of a plant cell is a cell wall. That is why in plant cells, it would be a cell plate that will aid in the division, whereby it would form the cell wall. You understand that? Whereby it will form the crosswall. Remember how plant cells are set up? Plant cells are adjacent to each other, right? Adjacent like this. So crosswall is this one here that allows the material to move from one cell to the other. Those are like the crosswall, the cell walls, rather. And then in animal cells, you do not have such walls. You only have the cell membrane. So because of that, remember the cytoplasm is inside the cell membrane in an animal cell. Cytoplasm is the jelly-like liquid inside. So what will it do? It will infold, it would move inwards. Like I said, you have liquid in your balloon, you move it to inside, then it will spread inside, but through the division. So it will infold the cytoplasm because the cell membrane is constricting. Then the cytoplasm will fold, thereby dividing the cell into two. So that's what happens. So what was already initiated here is what will happen. Then you have your cytoplasm here with this one, and the cytoplasm again moving with the other one, whereby you have two cells. Maybe when we watch the video tomorrow, it will make more sense, ne? But yeah, guys, we are really out of time now. I will see you tomorrow, ne, guys? All right, I'm sorry. Bye. Enjoy the rest of your day. See you tomorrow, and thank you so much for the wonderful lesson.